All right, in this video, I'm going to go through a formal definition of work and energy. Let's start with work. Work is when you apply a force to an object, causing it to have motion in that direction. So work as a quantity is equal to the force applied times the displacement of the object. Now, an interesting thing about work is that the force only does work when it is parallel to the displacement. So if I have some object of mass, whatever, m, and I pull on it with a rope, let's say angled up at 30 degrees, and I apply this force, and then as a result, let's just assume this is a crate sitting on top of a floor. This crate moves over a certain amount of distance, then only part of this force would do work on the object, specifically the force that is parallel to the displacement. And so sometimes this formula is written as work is equal to force times displacement times the cosine of the angle in between them. See, this is the cos component of that vector. So you apply a force over a distance, and as a result, the object moves. Once the object is moving, we say that the object has energy. So work is when you push or when you pull and you make it go. Energy is what we say it has. It's a property of something that is moving. So you do work on something, and now that object has energy. What that means then is since that object is moving, or since it has energy, it has the ability to do work on another object later. Imagine, for example, a ball, and you push the ball with some force F, and then the ball is rolling along. If the ball should encounter some other ball and strike it, because of the force that you applied to the ball to make it move through some distance, this ball will be able to apply a subsequent force on the second ball, causing it to move, or doing work on it. So you do work on an object, you store that work inside the object. That's called energy. And then later, if the situation allows it, that object can do that work back on some other object, and then it loses the energy by doing work and giving it to the other energy, or to the other object. There's more than one way that an object can have energy. There's more than one situation or property that an object can have that we say makes it have energy. The most obvious that I've been talking about is kinetic energy. That's the energy that's associated with the object physically moving. So you push on something, a ball, it starts rolling across the top of the surface, and now it has kinetic energy. If it hits something else, the fact that it's moving and needs to be slowed down means that it has the ability to apply a force over distance. Alternatively, potential energy is when an object is in a position that it could do, that there's a force that wants to do work on it, and as a result, it could get energy that way. The most obvious form of potential energy that we're going to talk about in this unit is gravitational potential energy. And gravitational potential energy happens when, say, a ball is sitting on top of a hill. See, because it's raised up this height, h, the ball wants to roll down the hill. And if the ball is allowed to roll down the hill, then work will be done on it, and at the bottom it will have energy. So at the top, we say it has potential energy. It hasn't realized its energy yet. It's just a potential. That potential energy is due to its position. And the thing that's key about its position is that it's in a position where some natural force wants to do work on it. So we talked about pushing a ball sideways, getting it moving so that it could apply a force over distance in a collision or something like that. If we were going to do work to give an object gravitational potential energy, that would be as simple as lifting it up to a higher height. As we apply that force and move it through that distance, we give it more gravitational potential energy, and as a result, if we were to let it go, it could realize that potential energy by converting the gravitational potential energy back into kinetic energy. And then if we imagine finally that ball striking the ground, it could do work. It could apply a force over a distance to the ground as it lands. The unit for work and energy is always the joule. Keeping in mind that work is equal to the force times the displacement, that means 1 joule is equal to 1 Newton times 1 meter. If we want to think about this a little bit further, we could recognize that 1 Newton came from force equals mass times acceleration, was 1 kilogram per meter second squared. So if we wanted the true definition of a joule, it would be kilograms meter per second squared times meters, or kilogram meter squared per second squared. A joule looks easier to me when we're writing these types of questions. So you do work to give something energy, or that something does work to give up its energy. The energy can take the form of motion or position. By position, I mean a place where a natural force wants to do work on that object.